Hello,
Hello. Hey,
can you
man.
hear me?
Yes, yes. Can you hear me?
Okay, perfect. Okay. Yes, I can hear you. So now everything is okay.
Okay, good then. Can you hear me, Manish?
Manish, I
Yes, yes,
think he
I
need.
can. Yeah, yeah. I
Okay.
can hear you.
Okay, perfect. So now everybody is here.
Okay, okay. Uh,
Nice.
Let me share the screen here. Um, yeah, you guys can see my screen?
Yes.
Okay.
Yes.
I posted the PDF of tonight's class, and the video is ready. I'm just gonna edit the beginning of the video to cut like the time that we don't start the class, but I'm gonna post it tonight, and also the video of this class. And yeah, let's start here, and you guys can follow
Perfect.
later on
Did
the PDF here.
the video of first class?
What?
Did you already posted a video of first class?
No, I'm gonna post it tonight. I'm
Okay,
gonna
okay.
edit and
Yeah, it's
post
okay.
it there. Okay, and yes, and anything you guys just write on the chat or say.
Okay.
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 Okay. So
Okay.
tonight we're gonna take a look at the Ethereum theory, a lot of its components, the history, and about the whole protocol and the platform for developing the smart contracts. So yeah, let's begin. Definition of this platform is an open source, globally decentralized computing infrastructure that executes programs, and the programs are called smart contracts. We're gonna take a look at the smart contracts, like the theory, and when we are developing our smart contracts on the Solidity language, we're gonna take a look at them. And at the same as we discussed yesterday, it uses a blockchain to synchronize and store the system's state changes. And the Ethereum platform has this token called Ether that is a utility token. They created this token, this cryptocurrency, not to be used as a payment system like Bitcoin or Litecoin or Dash is what was created, but to be like a utility token. You use Ether to pay for your smart contracts, to pay for the gas, and this concept of gas we're gonna see today. And yeah, the comparison to general blockchains, it has some like similar features. It's also a peer-to-peer network that with the messages between the nodes are called the transactions. It has also this consensus rules and consensus algorithm, and the Ethereum has the ETH hash algorithm for consensus. And today's proof of work, but they want to change proof of stake. And the name of this change is called Casper. They wanted to do this to last year, but was like postponed, and maybe this year they're gonna change to proof of stake. Let's see what happens. And it's also a state machine that processes the transactions. So we have each block has a state of the blockchain, and all the transactions are messages to change the state of the machine. And also has like a distributed database, a ledger, cryptographically secured, stores all the data. All the data are in every node of the network, and also has a form of incentive, the reward. Every block in the Ethereum blockchain today rewards 3 Ether for the miner. And we're gonna see like the development cycle. Like the next hard fork on Ethereum is gonna be called it's like a sub release. It's gonna be called Constantinople. That they're gonna reduce one of the changes, that they're gonna reduce the reward from 3 Ether to 2 Ether, and they wanted to do this in January, but they postponed again because they found a a security issue, so they postponed to correct that issue. So they're going to release probably this Constantinople this year. And also has an implementation of a client of a node. We're going to see some clients in this class as well. And the purpose and the main difference of this new blockchain, it was designed to be a general purpose programmable blockchain that runs a virtual machine that could be capable of executing code. Like they saw the technology created by Satoshi Nakamoto with Bitcoin, like the blockchain, but the idea that we're going to see here of the creator was to, like, okay, so let's get this technology, and what if we can add code to this blockchain, to this distributed network, and we could like run code, we could upload code to this network, and we could like run code in this network. And the main difference, like the Bitcoin protocol, it has like a script language, but you can't do like a lot of things because it's not Turing complete. We're going to see this concept in this class. So they added a Turing complete programming language. One of the programming language for smart contracts on the Ethereum platform is called Solidity. We're gonna study this language in next class. But also has some other programming languages like Viper or LLL. But the main language used today is Solidity. Yes, so let's take a look at the history of this protocol. At the time, I think like 2012, maybe, they saw the potential of this technology, but some people wanted to do more stuff with the technology, not to be just like a system for exchanging money. So they had a problem. What we're gonna do? We're gonna fork this technology and like do some changes, or we're gonna develop from scratch a whole system from zero. So there was a young man. He's Russian. His name is Vitalik Buterin, and he's a skilled programmer, and he made a proposition, I believe, in the Master coin at the time. And the guys there, they saw, oh, this is good, but it's like it's too much of a change. But and they decided not to accept his proposition. So he started to work on his own project. And he co-founded, we're gonna see here, he co-founded with some other guy a magazine called Bitcoin Magazine, and he was writing articles for the magazine. And he first, I think 2014, he did a post on the Bitcoin Magazine explaining his idea, and like some guys reached to him and said, oh, this is a good idea. And the first guy that reached to him to help on the work on the project was called Gavin Wood, and he became co-founder and CTO of the Ethereum Foundation. And I believe today he left the Ethereum Foundation and he's working on Parity. It's another Ethereum node. And I put some links on the presentation, so you guys can check Gavin's website, and also a link that Vitalik wrote on the prehistory of the Ethereum protocol. Are you guys listening good? The audio is good?
Yes.
Yes, it's good. But I have a question about the programming languages. We can program smart contract using Solidity and LOL. So what is LOL programming language?
It's another language. We're gonna see in another slide here some smart contracts languages, but like the most used today is Solidity because it has a syntax really similar to JavaScript, and like a lot of people know JavaScript more than, like, for example, Viper or LLL. It's based on Lisp, I believe. So people use more Solidity, and we're gonna see some other smart contracts programming languages. Guys, it's like it's raining here in my city today, and sometimes like the connection gets lost. But if it gets lost, we connect again. But I think should be okay.
Okay, no worries.
And if it happens, I'll tell you on the chat. So okay. Let's continue. And this is the guy that created the protocol. That he had the first idea. So what if we upload code to the blockchain? We build a new system, a new platform, and we upload like code so it can run on this technology. And he was born in a city, I believe, like 100 kilometers from Moscow in '94. He was a really talented young man. I think his father showed him the Bitcoin technology, and he got fascinated and like co-founded Bitcoin magazine, and he was like all in the technology. And he had his first contact with Bitcoin in 2011. He co-founded a Bitcoin magazine with this guy, Mihai Alisi, and I put some link to the guy's Twitter. So if you guys want to check out his tweets and his other contacts, it's there. And yeah, as I said, he proposed a change, but it was not accepted. So he started his own project. And I think 2017, there was a rumor of him like being dead. And he proved with the Ethereum network that he was alive. So let just show it here. So there was a rumor that he was dead, and the price of the Ether like fell a little. And he posted a picture on Twitter with the current block. So he and the current hash. Like it's a hash you can't think that the hash should be true. So for example, if you take this block height, and every block has a hash, so it's like the digital signature of the hash. And he wrote the beginning of the hash to prove that he was like alive at that moment with the Ethereum technology. So if we go to this block, and if you see the hash that he posted, you let me see. Where is the? Oh yeah, the hash starting here. E2 F1 FC. So he proved that the block was real and he was alive at the time. So, and he posted another day another blockchain use case to prove the existence of you. So yeah, let's continue here. Oh yeah, and the Bitcoin magazine, I just posted a picture of the magazine. He co-founded the magazine, and I did put a link to his articles. And this is a post of him introducing the Ethereum protocol, the idea that he had. So if you go to his post, I think 2014. He explains the idea of the new platform, and at the time, people thought it was cool. And Gavin Wood reached out to him and started to help him with this new protocol. And like you guys could take a look with more time there. So yeah, and for us to talk about the fundamental characters on Ethereum, which I just posted a slide here on the fundamental characters on around Bitcoin. Like Satoshi Nakamoto, the guy that created the the Bitcoin network. I just posted it, this picture here of this guy. I forgot his first name, but he has like Satoshi Nakamoto in his name, and like a lot of people reach out to him, like asking if he was the real Satoshi Nakamoto, and he said, no, it's not me, it's not me. I think he lives on the United States. And some other guys related to the technology. Adam Back, that created the Hashcash proof of work algorithm. Nick Szabo, the guy that created the concept of smart contracts. We're gonna see him, see here the link of his article. And Hal Finney, that helped Satoshi at the early years of Bitcoin. And we have some main characters on Ethereum. We have Vitalik Mihai, that was the guy that co-founded the Bitcoin magazine. Gavin Wood, that became the co-founder of Ethereum, and some other guys here. And Joseph Lubin, later on, he created the Consensus, one of the biggest companies related to Ethereum. And some other guys here too. And we have some stages of development of this protocol. They released the white paper of Ethereum in 2014. They began to work on the platform, and on the next year they released the first stage of Ethereum. And the platform is going to have four main stages. They're called Frontier and Homestead. We are currently in Metropolis, and the last stage of Ethereum is going to be called Serenity. And this Metropolis stage has two sub-releases. They're called Byzantium, it's the current stage, and the Constantinople, as we said, it was supposed to be released in January of this year, but they postponed. So maybe this year we're gonna see this sub-release. And yeah, every stage may include some sub-releases, changes a little of functionality, and we're gonna see Ethereum has a different culture. Every sub-release is not backwards compatible to the previous releases. And I put here some sub-releases that have occurred to date. So we had Ice Age, the DAO. There was a hack on the network, and they had to do the stuff again. And so this DAO created the Ethereum Classic. And we had some other, like the Tangerine Whistle, Spurious Dragon, Byzantium, the current release, and the Constantinople. And I just put here some past transitions. So on the block 0, the Genesis block of Ethereum was the first release. It's called Frontier, the initial stage. It happened in 2015. The block 200,000, the first sub-release, Ice Age, introduced some exponential difficulty increase. And I think on GitHub we can check out every sub-release and the specification and more details on these sub-releases. So on the same year we had on this block the next stage is called Homestead. And next year we had the DAO hack, so they had to hard fork this. So we had the Ethereum Classic split. So this new network, Ethereum Classic, was born in 2016, and some other sub-releases like the Tangerine Whistle. There was you could do a denial of service attack with low gas costs, and they released this sub-release to work on that. And we had also the Spurious Dragon that added some replay attack mechanism. And we are currently on the Metropolis Byzantium third stage of the platform. and we're gonna have the Metropolis Constantinople sub-release yet to be released, maybe this year, and the last final stage of Ethereum is gonna be called Serenity, so maybe next year, in 2 years. So we have a culture of like innovation and always looking at the future.
Okay, so I have a question. It's like, so each one of these stages like update, right? Update with more security and more features, right?
Yes.
Okay, about and another question about the homestead. I mean, it was in March 2015, which means before the Ice Age, right? Or after? Because Ice Age it's in September
Oh
7th
yeah.
of
Yeah. Sorry, I think
2000.
I forgot to put to 2000 because it's like sequential. So sorry,
Yeah,
it was a typo here. Sorry.
yeah. It was just a question. Okay, no worries.
Oh yeah, no, thanks. Yeah,
Yeah.
they're all sequential here.
Exactly, yeah, and that's why it's like I thought to ask. Okay, perfect.
Okay, thanks. I'll change on the classroom this.
No worries.
Thanks.
What?
So yeah, the main idea of Ethereum is to be a general purpose blockchain. The original blockchain, the first blockchain to be released, the Bitcoin, was just a peer-to-peer electronic cash system. Yeah, that was the main idea, the main purpose, to be a secure way of transfer money peer-to-peer via internet, and is a consensus state machine where transactions cause a global state transition, as we saw yesterday. And Ethereum, instead of only just tracking ownership of cryptocurrencies, track the state transitions of this global general purpose data store. And the data store is this distributed database on the blockchain. So this general purpose blockchain, the idea is for you to load code into its state machine and run that code on the Ethereum virtual machine. So you can store the resulting state changes in the Ethereum blockchain. And so we have some components of this general purpose blockchain. It's also a peer-to-peer network, and Ethereum, when we talked about Ethereum, we are talking about the Ethereum main network. And I put a link here of the Etherscan Explorer. This is the main network. And when we go to this Explorer, we're gonna see more later on the course. This is the Explorer of the main network. If we put like, so for example here, rinkeby.etherscan.io, we're gonna we go to the Rinkeby Test Network Explorer. So this is also a network, but like a test net. So if you're trying out you're implementing your token that you want to release on the main network, you're gonna first like deploy maybe on your local blockchain that you can just mess around and do whatever you want, and then you test on the test net. So you could test out your smart contracts. You can even use like put out your token and use that, for example, in your company. So and you won't have to pay real Ether, because real Ether only exists on the main network. Like all this, people pay with like real money, and on the test net, like this is like fake Ether. We're gonna see on the faucets that is websites that you can get like fake Ether on test nets that cost like no real money. So you can get those fake Ether for free. We're gonna see when we're gonna explore the development toolkit how to get the fake Ether, and like get fake Ether to MetaMask so you can test out your applications. So yeah, the Ethereum runs on the main network, And we also have some consensus rules and consensus algorithm. And I put a link here to this yellow paper. The white paper is the definition of the platform of the protocol. What is it? What it does? And the yellow paper is like a more specific definition and like more mathematical definition of all the consensus rules and all the technical stuff that the platform must do. So I just put the link here if you guys want to check out later. And as we said, the consensus algorithm is currently proof of work. So you have to mine the blocks, like use electricity, use computing power to mine the blocks. But later on, we're going to have the proof of stake. And we also have the transactions. There are network messages. They includes like in a nutshell, the sender is the sender, the account sender, the recipient, the account that is receiving the destination of the transaction, the value that you can like transfer Ether, or you can do like a transaction with no Ether involved. Like for example, you publish a smart contract, you don't need to transfer any value. You just put some Ether to pay for the gas, and the gas is a concept we're gonna see here that pays for your contract, your code to be run on the blockchain. So you're paying the miner to run your code. So that's why you put some Ether to pay for the gas costs. We're gonna see this concept here, and also some payload. So when I showed you guys that I registered some data, like the football data, just for like testing. That data came here on the payload. So if you are like building an application to register data on the blockchain, the data is going to be here on this payload. And we have a state machine with state transitions that are processed by the Ethereum Inverter Machine and executes bytecode. Like the Ethereum Virtual Machine compiles the high-level language, for example, Solidity, into bytecode and execute this bytecode to the blockchain. And we have also some data structure that the state is loaded locally on each node, and it contains transactions and system states. So every node stores this state transition. I think they used the level DB of Google to store this data structures in every node. And we also have economic security, so the proof of work algorithm and the reward of today 3 Ether per block mined, and the clients, our implementation of the client software. And the most famous client that we have today is Get, the Go Ethereum, that is implemented in Golang, and Parity, that is implemented in Rust. So we have to talk about Turing completeness and this halting problem. Did you guys see the Imitation Game, a movie about Alan Turing?
I don't remember, but I think if I see the movie, I will know that.
Yeah,
I think yeah.
Is this movie with the British actor, and tells the story of the Alan Turing. It's really cool to take a look at his life and his story on the Second War. But yeah. So
I have a question regarding previous slide. If you
okay.
Yeah, here. Yeah. So you were talking about Rinkevi free ring. Is that a Rinkevi is a free account to test your virtual Ether? You can send or you can play around with this.
Yeah, the test networks. So for example, if we open
Yeah, trust.
MetaMask is a wallet on your browser.
Oh,
You can change from the we're gonna see like how to use MetaMask
okay.
on the later class, and you can change from the networks here. So if you put to the main network, like this is real Ether, and the other test nets like the Ropsten, Coven, or Rinkeby, you use like fake Ether. And you can also run like a local network on the port 8545, and you can also connect with some other nodes. So for example, via a RPC connection. So if you have a node, so for example, you upload your an application and you upload a node on the Amazon AWS system, and you open a port there. So here is you specify a custom RPC to connect to that node that you just uploaded there. But yeah, the three test nets you use like fake Ether. You can get this Ether. So for example, if you type like faucet metamask.io, I believe it's in the Ropsten network, and you can just request Ether, and it connects. You see, it connects with my MetaMask, and shows my address here. Let me just. I'm a main network. Let me see, and you see that the website refreshes and shows this address of mine, and shows like your balance. So you can donate your fake Ether to this website, so more people could use, and you could request Ether, like fake Ether, to run your applications. The Ether on the test nets are like doesn't have like real value, like that doesn't cost real money.
Okay.
Okay. And
So, yeah. Okay.
And anything you guys just say on the mic, okay?
Okay. Just for the last, another question from this is that data structure is predefined, or it's a customized user defined? Like, what I have to do with the data and the structure?
You mean the data structure?
Yes.
No, the data structure is defined by the yellow paper, and like you just download the client. So for example, we're gonna use in this course the Geth, the Go Ethereum, and you just download the client, and the client is the implementation of the client, and does everything for you. Like it has the system and the database. It created a database on your computer, and it does everything for you. So you don't have to think on that.
Okay, so it's like for the Geth one, so we are building a blockchain using Geth, right? It's like, for example, a private blockchain. When you type, for example, make Geth, so you are firing up the nodes that you already created and the accounts within these nodes, and just it's like to create the blockchain network, right? Or what is the purpose of Geth exactly? It's like the client's software for what? For creating the blockchain, or for what?
You can do both. You can create your local blockchain. We're gonna see here when we're gonna work with Geth. We can like create our Genesis block the way we want, and we can start like mining the blocks. So we create like a private network, and you can like test your applications on this like private local blockchain that you create, and you use the client, the Geth client, or you can use Geth to connect to the other networks. So for example, you download Geth, and you specify Geth to connect to the main Ethereum network. So you are another node on the network, and you can also you can specify, no, I'm gonna test my application on the Ropsten network. So you specify your client to connect with the Ropsten network.
Okay, so in case I want to create or to build a consortium a blockchain, so I can use on the same work machine, for example, to create two nodes, and for each nodes I will fire up a Geth client to connect them, right?
Yes.
Or should I?
Yes.
Yeah.
Yes. You specify the nodes to connect to like a specific network.
But I can use it on the same laptop and the same network.
Yeah, I think you
create-
can. Yeah, I think you can do that because you specify a directory, and that directory is gonna have the database of the blockchain. So you can specify like two directories, and each directory has a copy of the blockchain. So each directory should be like a node on the network.
Okay, and the last question, I'm really sorry, but I have to ask because it came to my mind. For example, if I create a private a blockchain with one node, and you created a private blockchain with your node, can we connect our blockchains together, and it will be a consortium blockchain in this case, or not?
I think you have to specify like the node that you're connecting.
Okay.
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 I think we have to define some protocols to connect both, both nodes. Some common sets of protocols.
Yeah, and there's like you talked about like a consortium blockchain, but if we download like the Geth, this implementation, all the data would be like public. It would have no like privacy. So if you want to have like a kind of a consortium blockchain using Ethereum, you could like download the Quorum client. It's a soft fork of Geth, but they did they copied all the Ethereum implementation, but they added some layer as we talked yesterday. So to add like privacy on the transaction, so you could communicate two nodes and do the connection with them with the transactions like in a private way.
Okay.
So yeah, back to the Turing completeness. So Turing created a system called a concept called the Turing Machine. That is a state machine that manipulates symbols on memory, so you could like solve problems, and like for example, Turing complete programming language is a programming language that simulates the Turing machine. So, for example, the Bitcoin script language is not Turing complete because you can't simulate a Turing machine. So that was idea that Vitalik and Gavin Wood had. So we're gonna create a programming language to implement this general purpose blockchain. So we could we could create this Turing complete programming language to serve as a general purpose programmable platform. So there's this halting problem, and Turing proved that this problem, the halting problem, it's not a solvable problem. The thing is, if given a specific program and its input, you can't prove that the program will not run like forever. So, for example, you have loops. So you could have a security issue, and you program would like run forever. So they had to kind of solve this problem. So the idea that they came up was like to create gas. So you gonna upload code to the blockchain, but what if your program like runs forever? What, like, you're gonna be using like someone else's computer forever? You're gonna like use all the resources. So they introduced this mechanism called gas. So the Ethereum virtual machine, it accounts for every instruction that your code runs. So for example, computation, data access, data storage, read of data, and some more. So they have they account every instruction, and each instruction have a predetermined cost of units of gas. So if you write like a simple program with just some lines of code, just little lines of code, it's gonna cost like this amount of gas. But if you write like a complex smart contract, so for example, the CryptoKitties, like a really big smart contract, like costs like more to be run, and for you to deploy this contract on the Ethereum network. So for example, you can deploy a simple contract on the blockchain, and you're gonna pay like, for example, 10 cents for it. But if you have like a 1,000 lines smart contract, you're gonna pay like way more. So every instruction has a predetermined cost. So every transaction must include an amount of gas that sets up the upper limits of computation that can be consumed when you're running your smart contract. So to solve this, like to solve this problem, you just say, okay, I'm gonna pay like, I'm not gonna pay more than this amount of to run my code. So let's give an example. So you say, okay, I'm gonna pay $10 maximum to run this code, and your code could like use like $2 to run your code. But what if your code like goes on a infinite loop, and it costs like forever? So when you say, okay, I'm gonna pay the maximum amount of $10, if your code like runs forever or like exceeds that money that you paid, it's gonna terminate execution when it reaches like $10. You're not gonna pay more than that. So every transaction that you run on the Ethereum network, there's a concept called like gas limit. You specify the gas limit that you are willing to pay for that transaction. So like this is a way of like solving this halting problem for your program not to run forever.
So it's like I have a question for the halting problem. It's like the code would be executed forever. So to stop it, or Ethereum, not we, Ethereum came up with gas, which means it's like the amount of ether that you will pay to execute the smart contract. So in your example for the $10, in case I say that $10 and the amount it's like the amount of executing this smart contract exceeded the $10 to $20, so I'm not gonna pay another $10, right? And but the program will keep will keep running, or it will stop.
It will stop when it reaches like, it's gonna execute, and gonna reach like $10, and like it's like you're paying to the miner to execute the miner that is like running your like. So for example, you just deployed a smart contract, and the miner that gets your code and publishes it on the blockchain, he's gonna like take his fee of the execution, It's like the same with Bitcoin, and it's gonna use like the gas that you put there to execute your code, but you're not gonna pay more when it reaches like $10. Like the execution stops, and I don't know if it's like a failed transaction, like the final result, but that's a good question. But
Exactly, because it's like, how can I know if, yeah, in case I have a smart contract like a CryptoKitty, which for me, I want to run this application not forever, but for 5 or 6 years, or to the end of this game, for example. How can I know the amount of gas that I will use, and the amount of ether to pay, for example, two ether or $10, or how can I know the amount to keep my smart contract up and running without any interruption, or without the failure in the transaction in the future?
Okay, good question. You don't pay for the future run of the code. You just, if you are the person that deploys the contract, you pay for the deploy of the contract. So your contract exists on the blockchain. So people that want to interact with your smart contracts, they're the ones who are gonna pay for the transaction of the interaction transaction. So you, the smart contract deployer, you just pay for your contract to be deployed on the blockchain. So you like giving birth to your smart contract on the blockchain. You just pay for it to be deployed. And people that want to interact with your smart contract, they're gonna pay for that interaction.
But it will be forever. I mean, if I want to deploy my smart contract, I want it, in case of a CryptoKitty, I want it to run for forever. So, and in a case of gas, if I will pay gas when I will deploy my smart contract, it will end up maybe to stop the smart contract of CryptoKitty. And in the case of the game of CryptoKitty, and the users who wants to interact with the application, at the end they will stop as well, because the original smart contract stopped, right or not? Yeah, maybe I'm thinking a lot about it.
No, it's a good question. But you pay for just for the deployment of the contract, and if you pay right, and your smart contract, like the deployment, like the gas used is like below the limit, your smart contract it's deployed on the blockchain. So people are gonna interact with your smart contract. So for example, CryptoKitties, you're gonna do a transaction to change ownership of like someone else's cat to you. So this is a instruction on your contract. So you like a function call, and this function call costs like some units of gas. So you're gonna pay for that execution of that function. It's like the execution of just one function is way less than the whole contract. So you pay for transactions on the blockchain. So a transaction could be if I'm not mistaken, transactions are only state changes. So we're gonna see here, when you're just reading from a smart contract, you don't pay anything. So for example, you have a smart contract that stores like I don't know, your vaccines. You just did a application. I'm gonna show you guys here. A guy that I worked with, I think Medium, yeah. I invite you guys to read his article. He did an application to register his vaccines to the blockchain. So when he deployed the smart contracts, his smart contract, he paid gas for that. So I'm gonna put here on the just post here on the
Yes.
classroom, so you guys can see that. So he wrote the smart contract. I'm sure, guys. Later on, you guys read this article. It's really good. It was a really good idea, and it's like simple use but a good use. So yeah, this is the code of his smart contract. He paid for this smart contract deployment. So so we have like this function, get data. That is the function that he interacts just to read for example, a vaccine that he registered. When you just reading data off the blockchain, you don't pay nothing, because you don't like changing state. You just like doing a read interaction. So yeah, I lost what I was talking about, but yeah, you just pay for transactions that change the state of the blockchain, because you're gonna use someone else's computational power to store more data, to change data on their database, and like a distributed database, you have to pay to change that data, to change that state. Okay.
Okay.
Okay, let's continue here. So yeah, and I put a link to an article that I wrote here, and you guys could read that. It explains like a little more of what gas is, and like the use, the unity, and some other stuff. Like it's a quick read, but explains a lot. So take a look.
And it's like the miner will get the amount of the gas, right? Because it's the amount of the computation power that used to mine or to send the transaction. So the miner or the validator, I think the validator will get this amount of gas as a reward, or not. Maybe I'm mistaken.
The one that gets the price that you're paying, the gas or the ether, like gas is in the form of ether. Yeah.
Mm-hmm.
They get that money because they're the one who gonna execute that. So all the other nodes, they're just gonna update their database on their blockchain. So this is a distributed database. So everyone, like of the consensus algorithm, consensus rules, everyone has to update the state. So every block, for example, you have the block 10 that has a state, and the block 11, the state is totally different. All the nodes in the network, they're gonna just just update the state change. But the guy there is gonna get the ether of gas is gonna be the guy that gonna like run mine your smart contract, your state change to the blockchain.
Okay. Okay, thank you.
So we got to this concept of decentralized applications, and like a decentralized application that we use like way before this all blockchain thing. We're gonna use like torrent like BitTorrent. This is a example of a decentralized application. Like it's a distributed network that has no middleman, and we used it way before than all these blockchain platforms. Yeah. So the first goal was just to implement a general purpose blockchain that could be programmed for like a variety of uses. This was the first idea that Vitalik and Gavin had, but this concept evolved into to a platform for programming like decentralized applications or dApps. Like you can have your as I showed here. Let me just show. Yeah, that article of this friend of mine. You have, for example, every decentralized application is not just like the smart contract. Like you could use your smart contract. You could interact with this smart contract in a, for example, IDE called Remix, or we're gonna see this IDE here, or just my Ether wallet. You could like interact. Sorry, You could like interact with a smart contract like here and using the functions, but we don't want to like interact with code with function calls here. We want like a real web application. So for example, let me see, CryptoKitties. Yeah, like the user wants to just access a website and like interact and to be like really easy. So you have the smart contract behind all this, and you have this website, this web application that connects with the smart contracts that run this whole decentralized application. So in a nutshell, like really simple definition, a DApp is a smart contract plus a web user interface, or a web application built on top of open, decentralized, peer-to-peer infrastructure services. Typo here. But yeah, in a nutshell, just a smart contract plus the web user interface. And this web user interface connects with the smart contract to like change state and retrieve data and do all the stuff that you decentralized application do. So this is the concept. And we have this concept of Web 3.0, like the third age of the internet. So we had the first web and the second web, like Web 2.0, where we could have like blogs, user generated content, responsive interfaces, interactivity. But we have this like new concept of decentralized applications that introduces decentralization with these peer-to-peer protocols, and it represents like a new vision and focus for web applications. You're gonna change for like a centrally owned application to applications built on decentralized protocols. So this is like the new concept of this new web. So we have like, for example, BitTorrent, like decentralized applications, IPFS. We're gonna see IPFS on the course. It's like you store data files on like a lot of nodes and not on a central server. And Orbit DB is like a database implemented on top of IPFS. So we have this new concept. So guys, it's like here 7. I believe there is like 11. Let's do a quick pause for like a coffee or bathroom, okay?
Okay, perfect. For 10 minutes, right?
Yeah, 10 minutes. When
Okay.
it's like 7:10, we see each other again. Okay.
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 Yeah.
So see you in a few minutes.
See you.
Guys, can you hear me?
Yes.
Okay,
Yes.
let's get back here. Okay, so we have this new age of the internet, introducing like this decentralized protocols, decentralized applications, and yeah, let's see how this goes on the future. So we talked about the Ethereum development culture, and I just put an example here. So the Solidity version changed again. When we are developing our smart contracts and using the Solidity language, like it changes like really fast. So I remember like in last year, like February, I was like I did a smart contract, and like 3 months later, I was working with that same smart contract, and the compiler of the remix like accused like this is a old version. You should like upload you should like correct this code because like this syntax is not like actual anymore. Like you had to change your code. So it changed like a lot, like the subversions, and we had a main like a big change last year, I think November, from the Solidity 0.4.25 to 0.5. So that's a bigger change. When you have like 0.5.1 to 0.5.2, it's like not a major change. But when you're going to study Solidity, we're going to see some like changes on the syntax, changes on the way you implement your code. So it's taking a look at the Bitcoin core developers. They have some conservative principles, like all the changes are backwards compatible. And the Ethereum development community, they focus on the future rather than the past. So like innovation is always the principle. They always think of rapid innovation, rapid evolution, and willingness to deploy like forward-looking improvements, always looking on improve, and improve. Let me just take it here. So there's a downside. So developers, we must remain flexible and follow the changes and upgrade our systems, because a lot of changes, like a new version could change a system that you made. So we must remain flexible to keep learning till we reach like the last stage of Ethereum, that is Serenity. But in the meantime, they have to be flexible and continue learning. And so, for example, the change from Solidity 0.4 to 0.5, we have to keep learning for the moment and learn the small changes on the programming language, and like upgrade our systems, and maybe migrate the users, the apps, the funds. But yeah, we this is a downside, but on the future, the platform will be like on a final stage on Serenity. But in the meantime, we have to keep learning and keep improving our code. Let's take a look at some Ethereum basics here. So we have the Ether units. So like Ether is like the biggest unit. So 1 Ether like equals to like I think 10 elevated to like 18. And I did Way is the small units of Ether. I put a link here. There's a really useful website called Ether Converter, and let me show you guys here. We're gonna use this. This is a really useful website. So when we are doing transactions and Web3 library, we use like the unit that the library works is Way, not Ether. So yeah, as I said, we have some like Ether and Finney. Finney is in honor of Hal Finney. And Szabo is in honor of Nick Szabo, the inventor of the term smart contracts. And we have some other units here. And so, for example, you're doing a application, you transferring like 15 Ether, or I don't know, like a application in your local machine that you're gonna transfer like this amount of Ether. You just use this website and you copy here the amount of Way, and you put there on your JavaScript code. So you convert this units, and it's good to know this. And we have also on the Web3.js library some functions that converts like so for example from Ether to Way, or from Way to Ether. When we're gonna study the Web3.js library, we're gonna study this conversions. Yeah, and the website link is here. And we have some wallets, like some main wallets to use. MetaMask, we're gonna explore this wallet. We have My Ether wallet. There's like a website wallet. I think they just upgraded the website, but you can, yeah, you can create a new wallet. You can access a wallet. You can interact with your smart contracts, and it's all here on the website. We're gonna explore this one later. And we have the networks that we already talked about. The main net where Ether is costs like real money, and we have the 3 test networks, and we can explore them and like upload smart contract to them as well, like the Ropsten, Kovan, the Rinkeby. We could like do our local network, and we can also connect to like a node on the internet. You just specify their RPC and you connect to that network. We have also the faucets, that is like websites where you can get fake Ether, and we're gonna explore like the faucets to get like Ropsten, Kovan, Rinkeby, and let me just see here, Rinkeby faucet. Yes, this one. Let me see. Yeah. So let's say we want some fake Rinkeby Ether. This website, like they explain here, you just like, so for example, we select the Rinkeby, we connect to the Rinkeby network. We just close it here and here too. So MetaMask, we connect it. Let me just expand here. Yeah, so we are in the Rinkeby test network, and let's say we want Ether to, let me see. Yeah, this address. We copy here the address, and we have to like post the address on one social network. So for example, you can use like Twitter, Google Plus, or Facebook. So let me see, Google Plus. I don't think anyone uses it, so it has a function now, and you can just I don't know, you just post a post here, and you like copy the link of your post, and you post here the link of the post on the social network, and you just ask like, give me Ether. So for example, you can ask 18.75 Ether, and you just wait for like the blocks to be mined, and you receive your Ether here. You're gonna explore like these faucets in one class. You guys are talking. Okay. Yeah, the explorers that we already talked about, and you can do your own faucet. You can do an application, and you can deploy a smart contract and send Ether to that smart contract. You're gonna see this later on the course. Smart contracts, they can store Ether on their address. So you could develop your own faucet, like your web application, your address there that connects with a smart contract that you developed. And let's say you want that smart contract to be your private, just for your use, Ether faucet. So you send a lot of Ether, let's say Rinkeby Ether, to that contract. The contract stores the Rinkeby Ether that you sent, and you can make your web application to connect with your smart contract, and you can put a button on your website give me 1 Ether. So the website's going to connect with your smart contract and call the function, for example, give 1 Ether, and you specify on the website your address, or it connects to your MetaMask, and you just click on the button, and they sign a transaction for you, and you receive your Ether. You can develop your own faucets. That's the way how they. So for example, I think faucet. Yeah, that's how this faucet is implemented. This is a web application that connects with a smart contract. So this smart contract here has 851 Ether. This smart contract stores all this Ether. When you click this button, request 1 Ether from faucet, you're gonna this web application connects with the smart contract and calls the function to transfer 1 Ether to your to this address that is connected to your MetaMask. Yeah, and let's talk about some account types. There's 2 types of accounts in the Ethereum platform. We have externally owned accounts, that is accounts of users. So for example, you, me, we can create accounts that as the way we want. You can just go to MetaMask and click create account. You can have infinite accounts, and every account has a public key and a private key. So the private key is your own private key to access that public key, that account. But contracts, they do not have a private key. They are just contracts on the network, on the Ethereum network. They exist in a specific address. So when you deploy a smart contract to the network, the smart contract will have a specific address, and that address is the address that your web application is going to connect to and do all the transactions. Are you guys listening good? Is the audio good?
Yes.
Yes, it's good. So I have one question about this. I mean, so for a smart contract, there is no private key, so it's only a public key to execute the smart contract. It cannot be a hidden smart contract in the network. It should be a public, and that's why it's using a public key, not a private key.
Yes. Actually, there's a concept different. A public key is not the address. Address is derived from a public key. The public key is derived from the private key. But yes, the address of the smart contract is public. You just have to know the address. So for example, if you could use my Ether wallet and specify the website change that I have to Yeah, the missing the vintage my Ether wallet. You can click. Yeah, this was the previous interface here. You could just like go to contracts, and here you specify see the contract address, and it's gonna like appear the contract, and you just specify the ABI JSON interface, and you click access, and the website is gonna show you all the functions that you can interact with the contract. But yeah, answer your question. The contract address is public for people to interact with it. Okay.
Okay, perfect. And the JSON interface, it's here. What kind of code we should put? I mean, in the JSON.
Let me show you. We're gonna explore this on when we're gonna use Remix. So this is a simple code of a simple ICO, and when we're gonna use Remix, we're gonna go to run. And so, sorry, what was the question? Yeah, the JSON interface. Okay.
About yes.
Okay, so yeah, this is the so for example, we have like the code here in the high level programming language, and we also have the ABI. When you click details, it's like in the JSON interface. Let me see. You can click here, and let's see. When you put here, this is the JSON interface of your smart contract. Yeah, it has all the data, like the functions, the outputs, if the function is payable or not. So you just copy this ABI, this JSON interface, and you just have to, for example, if you're gonna use interact with the contract on my Ether wallet, you need the contract address. This is the address of the smart contract deployed on the blockchain, and the JSON interface. So if we deploy, so the three of us deploy the same code on the blockchain. The code is the same. The ABI of the three of us is going to be the same, but when we click deploy, the addresses are going to be like different. So that's why you need to specify the address and the JSON interface.
Will you please show me the ABI there in the console in Remix?
Okay.
The objects or the array you are showing here in this.
You just go to this tab, compile, and you can go to either details.
Yeah.
And
okay, it's like an object. It's an array.
Yeah, just an object. And you can just click here to copy the value to the clip to the buffer. When we're gonna use Remix, we're gonna explore all these functionalities. Okay. And for example, when let me just change here to like a local blockchain. This is like a smart contract specifying a simple ICO, and I'm gonna just specifying like 1,000 tokens. When I click deploy, this IDE lets us interact here. So you see that this is the contract on the address of the contract on this like local blockchain on the browser. Let me see. I think we need to click here. We copy the address of the contract. Like this address is like a contract deployed on the like a browser JavaScript simulation blockchain. And we have some other options here. We're gonna explore here this on the later class. When you click inject Web3, you connect to your MetaMask. So if your MetaMask is you saw that it changed the address. So this is the address that I have here. Let me just reject this. Okay, so when let me just expand here, please. So this is the address of the Rinkeby test network. And the remix, when you select injected Web3, it connects to your MetaMask, and MetaMask is connected to the Rinkeby test network. So, okay, let me see if I have more accounts with more Ether. No, let me just change to Ropsten network. And you see the remix asks for reload to reconnect with your MetaMask that just connected to the Ropsten. So the Ropsten, I have some Ether to deploy the contract. So when we go here to run, we are connected to the Ropsten network via MetaMask. And let's say we're gonna deploy like 1,000 tokens. Click deploy. It's gonna open a window for you to confirm that transaction on MetaMask. You click confirm, and this contract is being deployed on the Rinkeby, on the Ropsten network. You see that there's a transaction pending here. And when this transaction is mined on the Ropsten network, we're gonna see here the link to the transaction, and we're gonna have an address of this smart contract deployed to the Ropsten network. Like it takes like I think a minute, but shows here. Yeah, MetaMask says the confirmed transaction, and when you click here, like opens the Explorer, and like this is the hash of the transaction, and we just take a short time to show you all the details of that transaction. But let me see. Remix, it also shows the transaction here. When you click here, shows some data of the transaction. So transaction mined and execution succeeded. And you have some information here from this address. This is that was the address that deployed the smart contract to. So this is the construction of the smart contract, and I believe if you click here, you're gonna have the address of the just the name, and shows the how many gas was used, the cost of the transaction, the hash of the transaction, the input. I believe in hexadecimal. It was when I said 1,000 tokens. And a decoded input, so 1,000 here that specified, and you see the value is how many Ether you sent to the transaction. So we sent 0 Ether here, 0 way. It was just we paid for the transaction, and we didn't send any Ether here. Yeah, and this is the address of the contract. And this is in this address, the contract exists on the Ropsten network. So if we click here, let me see. Yeah, we copied the contract address, and we go to Ropsten .etherscan. We go to the Explorer, and if we put this address, it's gonna show us. This is the address of a contract that was deployed on the blockchain, and it shows the transactions. This is the hash of the transaction. If you click here, shows us exactly, I believe, yeah, this transaction link, and yeah, all the data that was on the transaction. So yeah, well, okay. What we were talking about, about account types. So yeah, we have the contract address that we saw here that has no private key, and the externally owned accounts. If you go to MetaMask, let me see, we could, the externally owned accounts, they have the public key. This is the address, and we can also get our private key here when we click. So the externally owned accounts have the public and the private key. That's the difference.
Mm.
If you guys have any questions, you just say okay.
Okay.
So we go to the developer tools list or the developer kit, and we have, as we saw, like some clients, like the Get, the Go Ethereum implementation. Parity is on Rust, and All ETH implemented on C++. So we have like the browsers or wallets, MetaMask that we just saw. Mist is a desktop application. It's kind of as Ethereum wallet. Ethereum wallet, when you go to wallet, I think on wallet.ethereum.org. Yeah, it's a web wallet that connects with MetaMask, and you have all your accounts. You can deploy contracts here, like the same. We're gonna explore this more. Yeah, and the programming languages, we have Solidity, the most used Ethereum programming language. It's compiled to bytecode. We have Remix, that the browser IDE that we just saw. We can so like you don't develop like a lot of big projects on Remix. You use like frameworks and like editing like more complex IDEs. So for example, Visual Studio, Visual Code, like to develop your applications. You use like frameworks, development frameworks. So for example, Truffle, we're gonna explore Truffle to develop, to deploy, to test our contracts. Remix is just like for learning and like for quick deployment. And we have Web3.js is a JavaScript library for network interaction. When you make your website connect with the blockchain, you use this JavaScript library to call all the functions, to sign transactions, to deploy contracts, to get access to contracts. And this Ganache is a simulation blockchain. Is like simulates a local blockchain on your computer, and it's really useful for testing your applications. So let's take a look at some clients. Every client is a implementation of the Ethereum specification as specified on the yellow paper, and each client communicates over this peer-to-peer network with other Ethereum clients, and all the clients, they are like interoperable. So if you're using the Get and you're interacting with some nodes, for example, using Parity, they connect with each other, yeah, even though they are like implemented in different programming languages. And every Ethereum client is open source project. The major clients are all available under open source licenses. You can download them for free and use for any purpose. And like every client, they implement the formal specification. That's the yellow paper, and the yellow paper defines the standard behavior of all the Ethereum clients, what they should do. And yeah, there are a number of independently developed interoperable clients, as we just saw. And the 6 main implementations is the Get, the Go Ethereum, written in Golang, the Parity, written in Rust. I believe like Gavin Wood, he left the Ethereum Foundation and he's working now on the Parity. So he's kind of competing with the Ethereum Foundation. We have the C++ Ethereum client written in C++, the Pi Ethereum written in Python, the Mantis in Scala, and Harmony written in Java. Like people use more like the Get and Parity clients. And let's take a look at some transactions, and this is important for our applications. So transactions are messages on this peer-to-peer network, in their starting point of every activity in the Ethereum system. They are kind of the input that causes the Ethereum Inverter Machine to evaluate contracts, update balances, change the states, and all the transactions modify the state of the Ethereum blockchain. So it's like other definition. There are signed messages originated by a EOA, and it's a externally owned account, as we saw, transmitted and recorded on the Ethereum blockchain. So we have here an image of how a transaction is processed. So you have your application and you sign your transaction with the client, or for example, Remix that we saw, the software does everything. So this example is we are signing a transaction with my Ether wallet. So you sign your transaction and you broadcast your transaction to the network, and then your transaction goes to my Ether wallet, and that website, my Ether wallet, they connect to a node. So for example, to a node on the Ethereum network. They could connect to a node via Infura or ETHScan, and they broadcast that transaction to a pool of all signed transactions. So when we saw that our transaction was pending, our transaction was in the pool, waiting to be catched by a miner for the transaction to be mined and included into the blockchain. So the miners, their big transactions. So of course, the transactions that pay higher gas prices, they're picked first. And once the miner pick your transaction and mine your transaction, and they include your transaction in a block, there's when we have like the transaction confirmed. So after the transaction is mined, it's put on the blockchain. So now we can interact with either the smart contract, or if you're sending Ether to another account. So this is how the process works.
Okay, I have a question about the Infora. Infora, so what it's like Infora or Ether scan. So what is this stage? It's like stage 3. What will happen? I didn't get it about Infora, I mean.
We're gonna see Infura when we're gonna see the developers toolkit. The Infura is like a service that you use to connect to a node. So for example, you use the website Infura to like create an account, and they give you like a code for you to put on your application. So your application connects with a node on the Infura service. We're gonna explore this more. So in this example, the website My Ether Wallet is connecting to a Infura service, and this Infura service like provides some nodes for you to connect. So when we're gonna explore the My Ether Wallet, we could select like what like kind of provider that we want. So you can choose like a kind of server. Like you choose what server do you want to connect. It's like
Exactly. Yeah, it's like to choose what server or the pool that you want to send your transaction to be picked up by the miner and validated and put it in the block, right? It's like to choose the pool that you want your transaction to go to. Okay.
Yeah, perfect.
Okay.
So I also have the question. Let's say your all transactions have equal priority. I mean, they are in equal gas price. How the miner will pick the transaction? Is it like a first come first serve basis, or like random? Like how?
Yeah, I believe there's like a queue for transactions. I never looked like all this in detail, like how are the transactions are picked first, but but for example, I believe is for example, you have some transactions here that you pay higher gas price, and others here that are like in the second place of the queue, and some guy here in the third place, like paying more higher gas price of you here, but like since you are on first on the queue, your transaction is picked, because otherwise, like a transaction with like low gas price would never be picked. So they have to be picked at some time.
So let's say me and Bashim both have a same gas price, and we both are doing a transaction here in the pool. So miner will pick according to based on timestamp or random in between us.
I don't know how the complexity of this thing, but I believe it's like more of that, like because the transactions have to go to be mined at some time. So it's like it's a more complex thing, but I believe like it's this way.
Okay, yeah, makes sense.
Okay. And let's take a look at the structure of a transaction. Every transaction has some components, and they have like a nonce. A nonce is a number of confirmed transactions originated by the sender's address. The sender is the account that is generating that transaction. And we have the gas price, that is the price of gas specified in way, not in ether, that the sender is willing to pay. So, for example, it's the same as it's kind of the price that you want to pay for a Bitcoin transaction. If you pay like a higher fee, your transaction is going to be like it's going to be mined faster than a transaction that you was just sent at the same time, but it's paying like a lower price. Like it's the same concept. And the gas limit that we just saw is the maximum amount of gas that you're willing to pay for the transaction. And if you put a gas limit and your code like exceeds this gas limit, your code will not, you stop executing. And I invite you guys to read that article that I wrote, and there's the link there that specifies like more, explains more things about the gas, like the gas price, gas limit, and all the things related to gas. And there's the two. The two is an address, and is the destination of the Ethereum address. So if you're just sending Ether from one account to the other, this two is like the destination address, and this two could be a contract address on a transaction that you are interacting with a contract. The value is the amount of Ether to send on the transaction. Could be 0, as we saw. The data is the variable, like a length variable. There's a typo here of a data payload. And these three VRS, it's like three components of elliptic curve digital signature of the originating externally owned account. This is like more complex. I never took a look at this elliptic curve digital signature algorithm, but and we see that there's no from address, because the externally owned public key can be like derived from this data here. So the software that we use, like they derive the from address from these three components. And we have an example here in a JSON format, in an object format. So we have, when we gonna like build a transaction, we build an object. So for example, this is the name of the variable of the object, signed transaction, and we specify the object attributes, so the nonce. And here we see that the first time the Web3 JavaScript library, we have this Web3 object, and we calling the one of the library function dot 2x, and so this is the first transaction that this address is making. So this is the nonce, zeros, like the first transaction of that this address is making. And you guys see that all these data are to hexadecimal value, not like a decimal. So we specify gas price, and you just call web3.2hex. And so this is the gas price that we are willing to pay. And this here is in Wei, not in Ether. The gas limit that we are willing to pay. The 2 is a destination address. This is the value. So you guys see that there's like a 1,000 Wei that is being transferred to this address. The data encoded in hexadecimal, and the 3 elliptic curve algorithm values. And like the client does all this and puts a hash, and when the transaction is mined and confirmed, we have the transaction hash ID. So this is an example of all this here.
Okay, I have one question about this transaction. So, for example, you are transferring a 1,000 Wii, but you are paying more gas than the transaction itself, right? Because the gas price is 2 and 10 zeros maybe, which is higher than the 1,000. So maybe you are transferring a money or a Wii money to this address, but you are paying gas more than the money that you are transferring, right?
Yeah, good question. But these are two different concepts. The gas price is the fee that you're gonna pay the miner to mine your transaction, and the gas limit is the amount of gas that you're gonna pay for the execution of the. So for example,
but I mean, I mean the value equal will be 3.2 hex a 1,000 V. You are transferring a 1,000 V to the address, but you are paying the miner a 10 zeros. You are paying the gas price more than the value, right? So it's like I will transfer a $1 to you, but I will pay a $100 to transfer this $1 to you.
Yeah, but okay. Let's say we are using. We're gonna transfer. You want to give $1 to a person in a different city, but you're gonna pay like, okay, let's say $100 to one person, and you're gonna pay like a $50 to the other person. So the person receiving $100 would like do the transaction faster. But that's a good question. I got this image from the internet just to specify, like do an example here. But there's a website called Gas Station Ether. Yeah, ETH Gas Station, that shows a lot of information about like gas price, and we see that the gas price is not on Wei, but in G Wei. So let's see, Ether Converter online. So we see here that we have Wei and we have G Wei. So all the gas prices are shown here in G Wei. So we have some information. So like the current gas prices and some statistics here. So they say like the standard gas price in G Wei is 3.5. So let's see if we put here G Wei. Yeah, this is the how much Wei you paying for the, you specifying for the gas price. So yeah, and the gas limit is a good question about the gas limit. because it's specified in way as well.
Mm.
But this website is really useful for you to.
But this standard will be fixed constant, or it will be like a variable. Sometime it will change. Like this is standard a safe value in the past.
Yeah, this is changed. This changes because if the network is like being used a lot, so we had in November, December of 2017, like the CryptoKitties, like it like overloaded the Ethereum network. So a lot of people wanted to use the network. So the gas price it went up because like it was a high demand on the network. So if you open this website on that time, the gas price was way higher than this. So they say here, if you want to make your transaction fast, you just specify like 5 GWay, and your transaction will be confirmed faster than if you specify, for example, 3 GWay.
Okay, perfect.
There's all the components of the transaction example, and I put an image from Remix that when we deployed our smart contract, the Remix on the console tab shows like some data, some values of the transaction. So the status of the transaction hash, from address to address, like how much gas was used, the transaction cost. And on Remix, we can also specify the gas limit that we want to for the transaction. The same here, the hash of all the data, the input, the decoded input. So we, for example, on the simple ICO, I just put like 1 million tokens, and like no Ether was transferred in this transaction. And we're going to explore more transactions when we're going to use like Geth. So we got to the concept of smart contracts, and smart contracts are nothing more than just programs on the blockchain. And this concept was invented by Nick Szabo in 1996, and I put a link on his page at the time. And a definition that he used, like a set of promises specified in digital form, including protocols within which the parties perform on these promises. So you have some rules on the smart contracts. It's just a program that runs on the blockchain. And if you go to this link, goes to the article of his website at the time, 1996. And he specifies like the concept of the smart contract. If you guys want to check out later this. And I just put here some smart contracts examples of programming languages. So for Ethereum, we have like the main used languages, Solidity, and also Viper. I put some link, I believe, for their GitHub.
Okay, I think you said in the beginning there is LOL as well. We can use three programming languages: Solidity, Viper, and LOL, or maybe
it's actually called LLL language.
LLL.
Yeah, like a Lisp implementation, something like that. Solidity LLL, like Lisp-like language.
Lisp-like, okay.
Lisp-like, yeah.
Lisp-like.
I heard.
Okay.
And
thanks.
EOS, they use like C and C++. Cardano use a language called Bluetooth. Waves use a RIDE language. And I put some links here for like comparison of some smart contracts programming language. This is a good article about like what's a smart contract, and comparison of all the languages. So we have Bitcoin uses the Bitcoin script. EOS uses C, C++. Ethereum uses Solidity. Ethereum Classic, Solidity 2. And Neo, they use like a lot of implementations here. Let me see the other articles. And this another one, comparison of smart contract platforms. And I think they refer to that last article there. Does a comparison of the smart contracts. If you guys want to check out later.
Okay.
And let's just talk a little about tokens. We're gonna have the token economics and ERC20 tokens class. Let's just do some definitions here. Token is like an old English word that means like a sign or a symbol, and can be used to refer like items of intrinsic value, such as like transportation tokens, laundry tokens, arcade game tokens. And like related to blockchain technology, they mean like abstractions, like digital abstractions that can be owned and that represent like assets, currency, like access rights. And if you go to like this page on the coinmarketcap.com, we see, if you go like here, we see like all the cryptocurrencies and all the tokens. If we go like coinmarketcap.com/tokens, we see all the tokens that were built in blockchain platforms already existing. So for example, a lot of them are just like ERC20 tokens, like that we're gonna implement here on the course. Like the Binance coin, I believe they reached like an all-time high this last week, implemented on Ethereum, the basic attention token, True USD also on Ethereum, on MySGO, and like a lot of them. They're all ERC20 tokens like implemented on the Ethereum blockchain. And like they all have a price because of the intrinsic value that they make. So for example, let me see. Yeah, the Binance coin is like a utility token implemented like as a ERC20 token on Ethereum, and they use that token as a utility. If you use their exchange, you're gonna have discounts, and also has like a price. So these are the cryptocurrency digital tokens. And like we are seeing a lot of research on this token economics, because we have like today there was a lot of news on security tokens. So for example, you want to tokenize art, and you want to like give shares of a company, so like a equity share. So there's today a lot of use for this like digital tokens. It could be currency, a digital asset, access, equity, like voting token, like the collectible. So the CryptoKitties are like collectible tokens implemented in another ERC standard, and some other uses here. And we're going to see more on the tokens class.
Okay, for here, I have one thing, like for the tokens. So we use token to, for example, create a new currency on top of Ethereum. And to do that, we use ERC20 token. It's one of the features. I mean, you can do it for a digital assets, for access, for equity, like you mentioned here. So there's ERC20, and I think there's another one, right? It's only two tokens where we can use two types of tokens.
Actually, there's more than two. Like all the tokens that we saw here on CoinMarketCap, they run on the standard ERC20, is an implementation, like a standard that we're gonna study here next week. But we have like the collectibles token in standard is, I believe, ERC 721 that the collectibles are implemented, and we're going to study like what changes from one standard to the other, and like this security token. So for example, you have a let's say like $1 million art, and you're gonna tokenize that art. So they are implementing, like they're discussing how to implement this like security standard, and it's not a standard yet, but they're discussing that on GitHub, like how to do like the perfect standard for all people to use. So you could like separate, so for example, art in like a lot of different pieces, and you can like own this asset in a digital form. So there's more than only two standards.
Okay, there's like many tasks for tokens. I mean, like you said, for the art, you use it, for example, to have an asset for this art. Is like your asset, and it's like a Creative Commons where there is a copyright on your on your art, right or wrong?
Yeah, for example, the ERC20 tokens, they are fungible tokens. So every token is like, you could replace one token for the other, and they have like the same value. So if I send to you like one Binance coin, and you send me back one Binance coin, like it's the same. But so for example, collectibles like CryptoKitties, every token is different from the other. So they're like unique. They're not like, they're non-fungible. So you have to have different standards, different implementations to deal with these differences. So for example, when you're gonna tokenize a asset, like for example art, you have to deal with this. Okay, so how we're gonna split in different like shares this masterpiece? So there has to be like a standard for that. So that's what they're discussing now. Okay. And like this is a simple description of the Ethereum virtual machine. I just put an article here on their wiki, but like it's like a complex thing on like how they did that virtual machine, how that operates. But just for us to know, is a virtual machine like the same as, for example, Java. It compiles high-level languages, so for example, Solidity, to Ethereum bytecodes, and those bytecodes are executed by that virtual machine. So like that's the main concept that we have to know to develop our applications. And I just put a link here to an article of glossary of all the Ethereum terms and Ethereum words. So if you guys have a doubt, you just go there. I took this from the Mastering Ethereum book. So a lot of words here and terms are described here. And yeah, I believe that's it, guys. And this is Vitalik thanking you guys in Russian.
Nice.
So yeah, and we see each other on Thursday when we're gonna study Solidity, okay? And we start building our smart contracts.
Okay.
Okay.
On Thursday.
Okay.
Yeah.
It was a nice tutorial and the presentation. You made it for us, and I really like it.
Okay.
Me
thanks.
too.
There's so many things we have to learn. I feel like
Yeah.
we don't know about anything. It's like a sea.
Yeah. I try to put like all the knowledge that I have to these presentations. So for you guys to study and like review that, to put all that to be there. But we're gonna learn together and share together.
Yeah, sure. Yeah.
Exactly.
Okay.
I really like the presentation as well. It's very nice.
Okay,
With
thanks.
it's like with a lot of information. I mean,
Yes.
yeah.
Thanks. And I'm gonna upload the video of this class and of last class here, so you guys can review and watch. For example, in VLC, that video player, you can like fast forward, so watch faster. So it's really good. And yeah, I'm gonna post here, and we're gonna start doing some exercises. And any questions, you guys just post here, okay?
Okay. Yeah. Sure.
Okay, perfect.
So see you guys on Thursday night.
On Thursday. Yeah.
Okay, till Thursday. Have a nice day.
Yeah, you too. Have a good rest there.
Okay.
Bye.
Okay, thanks. Bye.